And hi again. This is the last video, I think, for chapter 1. We're going to go over homeostasis. Homeostasis is the maintenance of a relatively stable internal environment. And so when we think of homeostasis, it's maintenance of everything inside the body, keeping all body functions at stable conditions. And so this is a dynamic state of equilibrium. So things are constantly changing, but we're always bringing everything back to homeostasis. Think about when you skip a meal. If you skip a meal, then your blood sugar is going to start to decrease, but your body is going to immediately respond by releasing sugar from cells to increase blood sugar back to where it has to go. And that's how homeostasis works. There are two major control systems that help to monitor homeostasis of all of our different organ systems. It's the nervous system and the endocrine system. These are the two control centers that we talked about before. And any imbalance in homeostasis results in disease of the body or disorder of the body. So let's look at the three parts of the homeostatic control mechanism. So the three components, you have to have a receptor that picks up some change, sends that information to the control center. The control center then determines how to respond to help bring that change back into balance. And the control center sends a signal out to an effector. The effector is going to be a muscle or a glandular tissue, and that is going to respond to that change and bring us back into balance. So receptors take in stimuli and send that information to whatever control center we have. The control center then determines, okay, what's going on, where is that set point supposed to be, and decides what response should happen. The control center sends a signal out to the effector, which provides a response to that stimulus. The most common type of homeostatic control mechanism is negative feedback. And what negative feedback does is it stops or reduces the intensity of the stimulus. So I always like to think about touching something hot. We've all done it, where you touch a pan that was on the stove and you don't think about it, and you touch it and your hand immediately jerks back. That's actually called oh, I can't think of the name. It's a reflex that we have. And it's a negative feedback reflex. The withdrawal reflex, that's what it's called. So you touch something, the receptors in your fingers send signals to your brain. Your brain says, ooh, that's really hot, and it's going to burn you, and sends a signal to your biceps to tell you to contract, and that causes your hand to move back away from that stimulus. This all happens before you even realize that you were touching something hot. And then you're like, holy cows, that was hot. And hopefully that response is quick enough to where you aren't even going to be burned, or you'll only have a small burn. So negative, and that's a negative feedback mechanism, and it's just like your thermostat. So here we have some imbalance, changing the variable. So a variable is supposed to be at some set point, and now we have an imbalance causing the variable to move. The stimulus is going to be picked up by a receptor. The receptor is going to then send signals to the control center. The control center is going to say, this is not good. We need to send a signal to the muscles or the glands, and the muscles or glands are going to bring about the change that occurs. And that's going to bring us back into homeostasis. Positive feedback is much more rare. There are a few mechanisms in the body that do use positive feedback. Blood clotting, breastfeeding, and labor are all positive feedback mechanisms. And what they do is it increases the original stimulus. It pushes the variable farther and farther away from set point. So instead of bringing us back directly to homeostasis, it pushes that variable farther away until a climactic event occurs, bringing us back to homeostasis. So I like to use birthing as my example. And so here's an example of positive feedback loop. That when the baby is ready to be born, so you will have hormones being released. The hormone is called oxytocin. It's released both by the baby and by the mom. Oxytocin is released from the hypothalamus, and it stimulates uterine contractions. So these contractions will then cause the uterus to shrink, causes it to push that baby towards the vagina, okay? That pushing causes the head of the baby to hit the cervix. The cervix is the end of the uterus. And when that happens, receptors on the cervix send signals to the brain, to the hypothalamus, to release more oxytocin. The oxytocin stimulates stronger uterine contractions, which stimulates the head, causes the head to hit that cervix even harder. And this is going to continue in the same direction until the baby is born. That would be the climactic event. So at this point, you should be able to tell me what the definition of homeostasis is, what positive and negative feedback are, and what the three components of the feedback mechanism are. And these are questions 13 through 16. So at this point, you have finished all of chapter 1, went through my lecture. If you've also went through the chapter, filled out the chapter 1 study guide, you should be prepared to do the quiz over chapter 1. Make sure that you are prepared because it is a timed quiz. And so once you start it, you will have only a short amount of time to finish all the questions. Good luck, and I will see you in chapter 2. Bye.